My name is Mike Petty, and I am co-founder and co-director of Loughborough Surface Analysis Limited. Our background is in semiconductors, and that's where all of our expertise has lain over about 26 years of being in business.
Loughborough Surface Analysis is a contract analysis laboratory that's based in Loughborough, and we specialise in secondary ion mass spectrometry, SIMS. It's a relatively small team, and we provide a confidential service with turnaround times of generally about 3 days from sample receipt. The main objective of this project was to develop a methodology that could be used for the characterization of potential contaminants in superalloy materials using a technique that is primarily applied to the semiconductor industry.
This project combines the strengths of LSA, which is SIMS analysis, and advanced microscopy, which is my speciality at WMG.
So SIMS is an analytical technique that uses a primary ion beam to hit the sample to ionize atoms or groups of atoms that we collect and sort by mass. What is really useful about SIMS is that it has a high sensitivity, so we can detect very low levels of impurities and contaminants, which is especially useful for the semiconductor industry.
Rolls-Royce, we are aware of the capability particularly of SIMS analysis, but we have previously been unable to utilise it. And this project gave us the opportunity to look at in-service components and also specimens that we had generated in a laboratory setting and understand the interaction of the materials that we use within an aero engine with the environment in which it is flying.
Right at the start of the project, obviously the first thing was to prepare samples. We're all aware that with microscopes, you need to have a good sample first before you go into the microscope. It very much dictates the quality of the results you get.
We were able to get unprecedented access to a sample set from Rolls-Royce of ex-service material, which was fantastic because that put us in a position where we were able to develop a method using the material system that we would actually be seeing if we were to take this into commercial setting.
So usually within the specimens that we had, we would take a macro section. From that macro section we could get large area maps using a technique we call energy dispersive X-ray spectroscopy, which allows us to map chemical composition across the sample. From that we would find specific features of interest. So for our industrial partners that might be something like a crack tip or a specific feature that they want to analyse. Then we can take further sections from that using the focused ion beam and then transition to the TEM, where we can again do energy dispersive X-ray spectroscopy. And it was in this system that we were able to find corrosive species on simulation samples.
It is very important for us to understand how our materials behave in certain environments to maintain flight safety, and understanding the level of detail that the SIMS and the microscopic analysis gives us over and above what we can do internally within our own laboratories gives us a lot greater understanding of what we can do to mitigate any negative effects.
It's a really wonderful example of taking a technology from one context and applying it in a completely unrelated context. In this project, we're talking about taking something from the semiconductor industry and applying it in the aerospace industry. Rolls-Royce have been very active really from the beginning of this project and supporting it all the way through, and I think that's been really beneficial to everybody involved.
No one technique can provide all the answers to everything, and by combining the high sensitivity with a technique that provides a high spatial resolution, you can provide an overall picture of where these complex chemical species are located and how they affect the materials.
What this project has allowed us to do is to explore exporting techniques that are used for materials characterization in semiconductors into a totally new materials area for us, which is superalloys. NATEP has helped in a number of ways. First of all, they've lubricated that process in terms of providing finance. They've brought us together with WMG and Rolls-Royce in a way that would never have really happened as formally as this, and being involved in a NATEP project has brought a discipline to the way in which we have gone about the work that we've carried out that we wouldn't otherwise have been able to bring into play being an SME.